Hello guys, um, I'm Ruben Pojok from the renowned University of Jos, Plateau State, and I'm your facilitator who is going to be taking you GIS by the program organized by the reputable body of OPSAN, that is the Urban and Regional Planning Student Association of Nigeria, on the program CAD Blast 2.0. In this course, we are going to be exploring the geographical information systems and its practical applications in the built environment. Okay, so stay tuned while we explore these courses. Now, the program is segmented into two segments. Part A we'll be talking about what is GIS data models and types of GIS data models. We'll also be looking at understanding GIS software's options and landscape. We'll also be taking coordinate systems, while the part B of this program is going to be structured on Google Earth Pro. This Google Earth Pro is very important. It's going to show us how we can be able to extract data for in order for us to be able to carry out our designs on ArcGIS or ArcMap. And part C, we are going to be now looking at ArcGIS in full, how to go about ArcGIS. So let's continue. Now, in order for us to understand what ArcGIS is all about, we need to understand terminologies, concepts, scope, and everything that GIS entails before you get into working with GIS, in order for us to understand it better. So I was able to coin out two little definitions of GIS. You can also do well to go there and explore more GIS definitions. Now, from here we say a geographical information system, GIS, is a system designed to capture, store, manipulate, analyze, manage, and present geospatial data. Now, geospatial data simply refers to all the features on the Earth's surface, whether it is a natural or anthropogenic. Natural in the sense that we have features like the mountain outcrops, the river bodies, the vegetation cover, the water bodies. These are all natural features and they are geographically located, so that's why we call them geospatial data. While anthropogenic features include all built up areas that man put his effort in building or constructing, like building, roads, structures, telecommunication servers, everything that is based on ground that is anthropogenic, that is done by human, is also known as geospatial data. And the second definition simply put it as a GIS can also be defined as a computer-based system to aid in the collection, maintenance, storage, analysis, output, and distribution of spatial data and information. Well, you might not know, if your hand has touched GIS in any ways, you have actually done what is called you have actually covered the definitions of GIS, because before you be able to work on any, whether it's GIS, ArcGIS or ArcMap or QGIS, whatever you call it, there must be a capturing of information, there must be a storage, there must be manipulation, analysis, management before you present your work. That's what we do when we come to CAD, that is computer aided designs. You just have to perform all these basic features of the definition of GIS in order for you to produce your designs or whatever, your proposals for decision making or for presentation or for defense or anything. Now, that is that about GIS. Let's quickly go to GIS data. There are three basic types of GIS model. They include the vector data model, the raster data model, and others such as triangulated irregular network, 3D data model, and we also have multiple models and so on. Now, for the purpose of this study, to get us going to understanding how GIS function, we are only going to focus our attention or scope to vector and raster data model alone, just to avoid complexities. Now, I want to quickly explain to us what a vector data model is. Now, a vector data model uses a set of coordinates and associated attribute data to define discrete objects. Now, the set of coordinates, we remember when we are doing our graph, we have the XY coordinate. is the same thing, is the same concept that is being applied into GIS. Every location or every spot that you find yourself, or a building or a structure, anything on the surface of the earth, is actually on a coordinate. Now the people who did this were able to structure the earth into 60 categories. I will come to that when I come to UTM. And then we have the lines of latitude and longitude that help us to locate objects accurately on the surface of the earth. Now each of those points, it has an x and y coordinate, which is also known as a latitude against longitude. So every design you do on your ArcGIS, you're actually working with coordinate system, and you're actually doing the work to the scale of what is actually applicable on ground. So the attribute simply means that supposing you digitize or design a plot layout for maybe high residential density, there is a collection of information we call attribute data or attribute tables. There you find the parameter of that plot, you find the area of that plot, and you can also do a lot of analysis from there of all discrete objects. Okay, I don't want us to read too much, so that will cause a lot of attention, but let's just try and understand the concepts. Now under vectors data, we have three types of sub vector data. We have the point, we have the line, and we have the polygon. Now a point uses single coordinate PS to represent the location of entity. The entities are the features. The features can be a mountainous outcrops, a water body, a building, a road, whatsoever. Now, and it's considered to have no dimension. Yes, it doesn't have a dimension. It's just a point. It just have a single pair of coordinate. For example, we have the gas well, the light pole, an accident location, or a survey point, or maybe a location where you have a normal occurrence of a crime or anything. You can actually use a point to spot those locations. Okay, now let me take us here. First of all, here at the left hand side of my screen, top left, you can see that we have the x-axis and the y-axis. I want to specifically use this to explain everything about, or the concept about GIS and how these are being done in the software. Now you can see that the x-axis has a number from 1 to 6. Also the y-axis starts from the y-axis starts from 1 to 6, and then the x-axis from 3 to 7. Now the black point here is basically telling us how a point feature can easily be plotted on a graph. Now this point has a pair of coordinates, that is 3, 2. Now in every pair of coordinates we have x and y values. So the x and y values is actually what we call the coordinates. Now let's now come back to the bottom right of the screen. Now this is the idea of what they try to do to explain what a GIS model is. Now supposing we are adding dimensions like longitude and eastings to our y-axis, and also latitude and northings to our x-axis, to define the real concept or the real scale on earth. It means that this point, the first P1, which was here, we read it as 3, 2, simply means it's on 3, 2 x and y axis. Similarly, we can also say that this point here is on latitude 3 and longitude 2, or we can say it's on northings 3 and eastings 2. That is just the concept, and that is what a line basically, a point feature basically stands for. It's just a pair of a coordinate system. Now let's go back. Now a line feature or a linear feature, often refers to as line or arc, are represented as line when using vector data models. Lines are most often represented as an ordered set of coordinate pairs. Let's go back. Now you see here we have a point here P1, and we also have another point here called P2. Now 2 points on any special location is a line. Now we have point 1 and point 2. By the time we draw a line to connect this point, we now have a line feature. That's why we say now it's a pair. We now have 2 pair of coordinate systems, such as P1 and P2, and P1 has a coordinate system of 3, 2. P2 has 7, 6. That is 3 on x-axis, 2 on y-axis, and 7 on x-axis, 6 on y-axis, just as x, y. Coming back to the real world, we can also note this as P2 is on latitude 7 degrees and longitude 6 degrees on northings. This northing 6 and longitude northing 7 and longitude 6. Thank you.